Hi guys, in this video we'll be looking at the factors which affect ionization energy. On my screen you're going to see a diagram which shows the first ionization energies for the elements of period 3. We are looking at the general trend in this first ionization energy across the period. The general trend will show us that as you go across a period, first ionization energy will increase. The anomalies we see on the screen, that is the decreases, we will address that in another video. So for now, we would like to look at what are the factors which affect ionization energy such that there is a general increase in the first ionization energy across a period. I'm going to state the three factors. We will look at their definitions before we look at how the factors are interrelated. So our three factors would be atomic size, nuclear charge, and screening effect. Let's take a look at what these mean. Alright, so I'm looking at my 3 points here. But before I do, I will just reiterate what is atomic size or atomic radius. The atomic size refers to the distance between the nucleus and the outer shell. So for example, this would be the atomic radius, the distance between the nucleus and the valence shell. Right, twice the amount of atomic radius would be atomic size. Right, so either term is acceptable: atomic size, atomic radius. The other factor which affects ionization energy is called the nuclear charge. In my definition, I've called it the force of attraction of the nucleus for electrons. Remember that in the nucleus there are protons, and protons are positively charged, and as such they result in giving the nucleus something called nuclear charge. So it is the attraction of the protons in the nucleus for the electrons that keeps the electrons in their electron shells. We've looked at atomic size, we've looked at nuclear charge. Let's look at what screening effect means. In my definition, I've defined screening effect as the shielding of the outermost electrons, and these outermost electrons are what we call valence electrons. By inner filled electron shells. This screening effect means that if there are inner filled electron shells, and I'm referring to completely filled electron shells here, they will shield the electrons in the outer shell from the attraction of the protons in the nucleus. Right, so screening effect refers to that shielding of the outermost or valence electrons by inner filled electron shells. As a result of this screening effect, the impact it has on the attraction of the nucleus for the outer electrons, we can then further go on to use a term called effective nuclear charge, where we can just specifically refer to the attraction of the nucleus for the electrons in this outermost shell or valence shell. So once again, nuclear charge would be the attraction of the nucleus for all electrons, and these are all electrons in the atom, whereas effective nuclear charge would look at the attraction of the nucleus for the electrons in this valence shell. We're going to go back up and look at our three factors and how they affect ionization energy. And in looking at my three factors, I will explain in a little more detail how they impact ionization energy. So let's start with this atomic size or atomic radius. Now the atomic size or the atomic radius is a reflection of the distance of the nucleus from the outer shell. This should mean as atomic size increases, we should have more electron shells in our atom, right? So that gives the greatest impact on atomic size or causes that increase in atomic size, right? Or great increases. So as atomic size is said to increase, meaning we have more electron shells in the atom, we would expect that ionization energy should decrease. And this is because first ionization energy looks at removing 1 mole of electrons from 1 mole of gaseous atoms to form 1 mole of ions with a single positive charge. The 1 electron that we are removing from each atom must be removed from the valence shell. So as atomic size increases, this means that electron in that valence shell is going further away from the nucleus. So it's going to take less energy to remove it. Let's talk about the nuclear charge. Now this nuclear charge refers to the force of attraction of the nucleus for all electrons. So we would expect as there are a greater number of protons in a nucleus, that nuclear charge should increase. Right, so as the number of protons increases, right, so the more protons we have in our nucleus, it means it should increase our nuclear charge, and hence that atomic size should also increase if we have more protons in our atom. Right, but I want to take it out here and I'm just going to refer to protons and nuclear charge. We are saying that as the atomic number increases or as the number of protons increases, right, so as atomic number increases or number of protons increases, this nuclear charge should start to increase. The more protons we have in our atom, the greater the nuclear charge. Taking this into consideration, we have to look at our third factor, which is called the screening effect. While we are saying the greater number of protons in an atom, the greater the nuclear charge, we have to keep in mind that in first ionization energy, we are removing an electron from the outermost or valence shell. What impacts the attraction of this nucleus for the electrons in the outermost shell would be how many inner-filled electron shells there are between this outer electron and the nucleus. That means we want to look at what is the screening effect. If we have a greater number of inner-filled electron shells, and I'm reading from screening effect here, as the number of inner-filled electron shells increases, that screening effect is going to increase, right? As screening effect increases, it will outweigh nuclear charge, meaning that it is going to decrease the attraction of the nucleus for the electrons in the outermost shell. Put simply, this means effective nuclear charge should decrease right? Remember, effective nuclear charge is the attraction of the nucleus for the electrons in the outermost or valence shell. We are going to look at how these three factors, atomic size, nuclear charge, and screening effect, change across a period in order for us to understand why this first ionization energy will increase. I have summarized in my notes how these factors change, and I'm going to go through it via my table and explain it to you. We are saying across a period, atomic size is going to decrease, right? This is a trend that you must learn by heart, right? Once you know that atomic size decreases, you'll be able to explain the other factors. It is known atomic size decreases across a period. Ongoing across a period, as the number of protons increases, the number of electrons will increase. This means the nuclear charge will increase. What we have to keep in mind is, in a period, the number of inner-filled electron shells is constant. For example, in period 3, we only have 3 shells, or each atom has 3 shells, and they should therefore have 2 inner-filled electron shells, shell 1 and 2. So that means for all the elements in the same period, they have the same number of inner-filled electron shells. This should tell us that the screening effect is constant. If that screening effect is constant, it would not outweigh nuclear charge, meaning it would not decrease the attraction of the nucleus for the electrons in the outer shell. With a constant screening effect, that means the attraction of the nucleus for the electrons in the outer shell will increase. Because of this increased attraction, this is why we have a decrease in atomic size. It's going to pull in the electron shells a little closer, and this is why atomic size decreases across a period. Because of this increasing effective nuclear charge, the attraction of the nucleus for the electrons in the outer shell, that first ionization energy is going to increase, meaning it takes a little more energy for each successive element to pull out an electron from their outer shell, and this is because of the increased attraction of the nucleus for the electrons in this outer shell. And this is my short explanation on the 3 factors which cause an increase in first ionization energy across a period. We have to take note: atomic size decreases, nuclear charge increases, screening effect is constant.